Hello, everyone. I'm Jorabella Abilia, and I am a PhD student under Dr. Stein, and today I will be presenting one of the experiments that we have conducted for my dissertation. And this presentation was also presented in the previous Midwest conference. So, this presentation is entitled Degradation of Dietary Fiber in the Stomach, Small Intestine, and Large Intestine of Growing Pigs Fed Corn or Wheat based diets without or with microbial xylanase. I would like to start with three take home messages. First, fiber hydrolysis already starts in the stomach of pigs. Second, fermentability of fiber in corn is different than in wheat. And third, this means that different enzymes may be needed to degrade the fiber that is present in corn versus that in wheat. So, responses to microbial xylanases has been greater in wheat-based diets than in corn-based diets, and the exact reason for this has not been fully elucidated. However, the degradation varies with structure and physicochemical characteristics of the non-starch polysaccharide. For example, the arabinoxylan that is present in wheat may have a different structure than the arabinoxylans that is present in corn. And also, the structure of arabinoxylans vary even within the ingredient itself. And so, it's possible that the arabinoxylan in corn may be more rigid compared to the arabinoxylans in wheat-based diets. So, there are different dietary fiber components that are present in our feed ingredients, and this includes soluble hemicellulose, insoluble hemicellulose, cellulose, and lignin. Hemicelluloses are also what we call non-starch polysaccharide. And to quantify these fractions, we have what we call acid detergent fiber. This quantifies cellulose and lignin. We have NDF or neutral detergent fiber. This includes insoluble hemicellulose, cellulose, and lignin. And then we also have the soluble dietary fiber, which is equivalent to the soluble hemicellulose, and the insoluble dietary fiber, which is basically the same as the neutral detergent fiber. So the sum of soluble dietary fiber and insoluble dietary fiber is what we call TDF or total dietary fiber. And we can also analyze the lignin fraction of our ingredients. And based on this analysis, we will be able to calculate the other dietary fractions. We will be able to calculate non-starch polysaccharide by subtracting lignin from total dietary fiber, insoluble hemicellulose by subtracting acid detergent fiber from neutral detergent fiber, and cellulose by subtracting lignin from acid detergent fiber. Because of the differences in the concentration of these dietary fiber fractions, the site of digestion of those dietary fiber fractions are also affected. Most of the soluble dietary fiber are fermented prior to the colon, and most of the insoluble dietary fiber are fermented in the colon. So clearly, differences in the digestibility of fiber exist among ingredients. And also in a previous experiment, they also observed that the digestibility of fiber in soybean hulls and DDGS was less compared to the digestibility of fiber in wheat middlings. And again, this indicates that we observe differences in the digestibility of dietary fiber fractions among ingredients. However, there had been no study conducted determining the digestibility of fiber in corn versus the fiber in wheat-based diets. And so the objective of this experiment was to test the hypothesis that microbial xylanases may contribute to the degradation of fiber in wheat and corn-based diets along the intestinal tract of the pigs. Moving on to the materials and methods, we formulated two diets based on two different sources of dietary fiber. We have corn-based diets, which is composed of 71.4% corn and 24% soybean meal, and wheat-based diets, which is composed of 73.75% wheat and 22% soybean meal. To increase the concentration of dietary fiber, we included 30% of DDGS to the corn-based diets and 30% wheat middlings to the wheat-based diets at the expense of corn and soybean meal. These four diets were formulated to contain no xylanase, and another set of these four diets were formulated to contain xylanase A, and another set of these four diets to contain xylanase B, for a total of 12 different diets. These 12 diets were randomly allotted to a 24 by 4 Youden square with 24 double cannulated pigs with one cannula on the proximal end of the duodenum and one cannula at the end of the ileum. and 4 periods for a total of 8 replicate pigs per diet. So each period consisted of 18 days. With the initial 7 days of adaptation period to the diet, fecal and urine collection on day 8 to 13, and ileal digestive collection on day 15 to 16, and duodenal digestive collection on day 17 to 18. We calculated the apparent duodenal digestibility. This reflects the digestibility of fiber in the stomach of the pigs. We also calculated the apparent ileal digestibility, and this reflects the hydrolysis of fiber at the end of the small intestine of the pigs, and the parenteral tract digestibility, which reflects the digestibility of fiber along the gastrointestinal tract of the pigs. So we calculated all of these digestibility values among the different fractions of dietary fiber. But for this presentation, I will only show you the digestibility of insoluble hemicellulose, mainly because more than 50% of the insoluble hemicellulose is composed of arabinoxylenes, and arabinoxylen is our main substrate for the microbial xylanase supplementation. I will also show you the digestibility of gross energy as well as the metabolizable energy of the diets. Moving on with the results. To set up the slides, the vertical axis represents the percent digestibility, and the horizontal axis represents the digestibility of each of the diet. Yellow bars represent diets containing no xylanases, blue bars represent diets containing xylanase A, and orange bars represent diet containing xylanase B. So we can observe here that there is a very low digestibility of insoluble hemicellulose by the end of the stomach. And this is expected because there is not a lot of microbial growth in the stomach of the pigs. And we also observed that supplementation of microbial xylanase improved the duodenal digestibility of insoluble hemicellulose in the wheat-based diet, but that was not the case in the corn-based diets. And this indicates that the structure of insoluble hemicellulose in wheat is less rigid compared to the insoluble hemicelluloses in corn. And also, we observed that addition of DDGS to the corn-based diets improved the duodenal digestibility of insoluble hemicellulose, which may be associated to the fermentation process of producing DDGS from corn. However, we did not observe an improvement if wheat middlings was added to the wheat-based diets, indicating that feed milling did not improve the digestibility of insoluble hemicellulose. And also, we can observe here that there's greater digestibility of insoluble hemicellulose in wheat-based diets compared to the corn-based diets, and again indicating that the structure of insoluble hemicelluloses in wheat-based diets is less rigid compared to the insoluble hemicellulose in corn-based diets. For the duodenal digestibility of gross energy, which is not in this presentation, we observed less than 5% or 0% digestibility of gross energy in the stomach, and this is expected because we don't have absorption of monosaccharides in the stomach of the pigs. This also indicates that although we observed an improvement in the digestibility of insoluble hemicellulose, we did not observe an improvement in the digestibility of gross energy. Moving on to the ileal digestibility of insoluble hemicellulose, again, we observed an improvement on the ileal digestibility of insoluble hemicellulose if DDGS was added to the corn-based diets. And again, this may be associated to the fermentation process to produce the DDGS, and thereby it's possible that through that process, some of the insoluble fractions of the fiber are solubilized. However, again, we did not observe an improvement if wheat middlings was added to the wheat-based diets, indicating that the feed milling did not improve the ileal digestibility of insoluble hemicellulose. And also, generally, we observed that the ileal digestibility of insoluble hemicellulose in wheat-based diets is greater than the ileal digestibility of insoluble hemicellulose in corn, and again indicating that the structure of insoluble hemicellulose in wheat is less rigid compared to that in corn. And also, we did not observe any improvement with microbial xylanase supplementation regardless of the grain source or the fiber concentration. For the ileal digestibility of gross energy, we observed a greater ileal digestibility of gross energy in corn versus that in the wheat-based diets, and this is expected because of the greater concentration of starch in corn compared to that in wheat. And also, we observed a reduction in ileal digestibility of gross energy if DDGS was added to the corn-based diets or if wheat middlings was added to the wheat-based diets because of increasing the concentration of the insoluble portions with the inclusion of these co-products. For the total tract digestibility of insoluble hemicellulose, again, as we have observed for the duodenal digestibility, we observed an improvement if microbial xylanase was added to the wheat-based diets, but that was not the case in corn. And also, we observed greater total tract digestibility of insoluble hemicellulose in wheat-based diets than in the corn-based diets. And again, this may be associated to a less rigid structure of the insoluble hemicellulose in wheat versus that in corn. For the total tract digestibility of gross energy, again, we observed greater digestibility of gross energy in corn-based diets compared to the wheat-based diets. And again, this is expected because of the greater proportion of digestible energy in corn versus that in the wheat-based diets. And again, we observed a reduction in the total tract digestibility of gross energy if DDGS was added to the corn-based diets or if wheat middlings was added to the wheat-based diets, because by including these co-products, we are increasing the concentration of dietary fiber and reducing the amount of starch in the diet. For the metabolizable energy, we observed a greater reduction in the concentration of metabolizable energy if wheat middlings was added to the wheat-based diets than if DDGS was added to the corn-based diets. And this may be associated to the fact that when there is a release of pentoses in the small intestine of the pigs and they get absorbed, some of those pentoses are excreted into the urine and analyzed as energy, thereby reducing the metabolizable energy of the diet. We did not observe an overall effect of microbial xylanase supplementation, mainly because we did not observe an improvement in the corn-based diets. However, if we will only focus on the wheat-based diets, we observed an improvement on the metabolizable energy if microbial xylanases were added. So to sum it up, the duodenal, ileal, and apparent total tract digestibility of insoluble hemicellulose in wheat-based diets was greater compared to the corn-based diets. And also, the digestibility of gross energy and concentration of metabolizable energy in corn-based diets was greater than in the wheat-based diets. We observed an improvement in the duodenal and total tract digestibility of insoluble hemicellulose and metabolizable energy when xylanases were supplemented to the wheat-based diets, but that was not the case in the corn. And also, we observed an improvement in the duodenal and ileal digestibility of insoluble hemicelluloses if DDGS was added to the corn-based diets, but we did not observe any differences if wheat middlings was added to the wheat-based diets. But the overall or the total tract digestibility, we did not observe any differences if DDGS was added to the corn-based diets or if wheat middlings was added to the wheat-based diets, indicating that the fermentation process to produce DDGS or the feed milling did not affect the digestibility of insoluble hemicellulose in these feed ingredients. Also, we observed that there's a reduction in the digestibility of gross energy and concentration of metabolizable energy if DDGS or wheat middlings was added to the corn or wheat-based diets, respectively. In conclusion, hydrolysis of fiber prior to the ileum is greater in wheat than in the corn-based diets, and there was no apparent effect of xylanase on dietary fiber degradation and metabolizable energy in corn-based diets. However, we observed an improvement if microbial xylanase was added to the wheat-based diets. And with that, I would like to acknowledge DuPont for funding this experiment and also the Stein Monogastric Lab for all the support and help for this experiment. And thank you everyone for listening, and if you want to know more, you can visit our website.